Just remember, if you do this, you're doing this at your own risk. This load is perfect for discharging your capacitors. So after you've messed around with this and you don't want to hurt yourself, then you can take this load and cross over your caps and get rid of all your voltage that way. Look what I got here. Zariba, American FarmWorks, same thing. This is typical of what you see. They'll start jumping and burning, and next thing you know, the whole thing's just burnt up. Like, here's a great example. Look how bad that got. Now typically I can get in here, clean all that carbon up, and get all this stuff fixed, but it's labor intensive. Situation like this may not be worth it, you know. Just depends. I clean it up and see, and you never know what it tears up. I mean, there's a big hole, but I got a way to fill the holes. I got a way to pretty much repair all of them. They just, you know, they get old and they'll have a break in the connection, like on this. They'll have a break somewhere and it'll start arcing, and all that power goes into that arc and just starts burning. These take a lot to repair because of all the time it takes to clean them up, but apparently you can't get these anymore. My guy is willing to pay for me to spend the kind of time it takes, mainly because I cut him a heck of a deal, but also because this is what he does all the time, and he's got lots of business coming in, so he needs to always have a good set of boards. And these transformers, this one here was one that I had rebuilt that quit. It's the only one out of 17, and I don't know why this quit, but I gotta look at that. The rest of these will get rebuilt. We'll save them. The problem with rebuilding these is if your secondary gets blown up, you start running into issues because the way they wound this up, it's almost impossible to rewind that bobbin. So I'll 3D print a bobbin, and I will match the impedance of that coil and use a home-built bobbin wrapped with my little computer wrapper, just a 3D printer that I built to wrap coils. If you don't insulate them like they've done here, they've got these little breaks. If you don't insulate them, you start having issues like the old M800s. So I usually insulate them with plastic, and sometimes it's paper, just depending on what it is. But usually it's plastic. I usually put an insulator on every wrap, that way, you know, it's got the best insulation on it. These actually put out quite a bit of power as far as on your primary. So if your primary is getting 9 to 10,000 volts, you really need a lot better insulator. You can use some pretty thin plastic, but you don't have a lot of room to work because you don't want that bobbin that you make, you don't want that stuff touching your metal. And we'll go through the process of checking components and figuring out, like this one, what may be possibly wrong with this. That way, you know, you guys can figure out how to repair a board if you've got one. If you have a method of your own that you could fill in these voids after they're cleaned up and there's holes and things like that, that's great. Another thing I've been doing is 3D printing these plugs, and I can make a good plug. There's extra connections in here, so I can pull the extra ones out, the ones that aren't burnt to a crisp like that, and use them in the new plug. So I can go through here and figure out how many plugs I need. Like a plug like that, you probably should go ahead and replace it, even if it could be cleaned up. Alright, let's tackle this one first. I didn't think there was anything major wrong with this, and I kind of thought, well, it's possible that maybe I'm going to put this on beat mode. It's possible that maybe we're not getting a good connection on this primary. What is the deal here? There we go. It's just me not pushing hard enough. So I don't see any problem with this. Now the secondary on this and this, and it's right. I'm beginning to think maybe his board on his quit or something, but just to be safe, I'm going to resolder these. There's a possibility that maybe it's not soldered real well. Yeah, that should be nice and soldered. Okay, let's check where you connect it. The primary is good. Secondary is good. So I don't believe there's anything wrong with that. Check this. I don't think there's anything wrong with this one. I will test that later. Let's try this one. Okay, this one may be blown. Secondary, we got 10 ohms. Primary, we have nothing. So this primary is gone. And the way I fix the primaries is I basically tear the whole thing down and reprint out a primary bobbin. Most of the time it's the primary. There's nothing there, so we got two primaries that are blown on these two. Just to give you guys an idea of what I'm talking about, these are the bobbins that I print. This is a primary, and this primary fits in the secondary. And the secondaries are usually, you can salvage the ones that are on there, but if they've blown them, then you've got to wind this secondary, and this primary fits in there. So on this one, as an example, this is one I have already repaired. This primary was blown, and sometimes to get the spacing correct, I'll have one of these, which is what this is. That'll fit in there and hold everything tight, so you don't get a bunch of bouncing around with this thing's firing. And that primary is sitting inside of there, and I reuse the secondary, as you can see. So that's the original secondary. I don't have any around here because it's not that often that the secondaries blow, so I don't have one here to show you, but that is the bobbin. It's got material on here to allow me to print this ridge. So this material that's in between the dotted lines actually comes out. And then all of this fits in the core, the E core. And then it's just a matter of, you know, putting everything on the board, connecting everything on the board. And the way I've done it, I figured out how much wire needs to be put out to impedance match. So if I make one of these, it's compatible with an existing unit. So if you have a 200 miler, then that allows you to be able to mix this with an old one. So as long as you match everything, then you're good to go. Let's look at this. Now, one of the things these are notorious for, like I was saying before, is they're burning. You can tell right off the bat this is burnt and it's jumping. Whether you realize it or not, that carbon, this power is high enough that it'll jump through that carbon and act like that carbon's a wire and go to this next connection here. So this has to be cleaned out, and all the carbon has to be removed. So this is obviously the main problem with this one. So let's check this one here, since we know what's in that. Get it cleaned up. That's just alcohol. Can you see what I see? It looks like this is broken, this connection. Yeah, because look. Okay, and if I come here, okay, so this apparently got hot and burnt. That's probably the only thing wrong with this. Most likely these things are all fine. Let me just go over a little bit. I've had some of these go out. It's rare, but sometimes your high voltage diodes will burn. If you have a secondary board and this is jumping over, sometimes the secondary board will get messed up and it'll blow these. You'll have something blown on here because of it. When you do have these boards here, this is where your power comes through. So your AC is going through here, and these two little doodads inside of these sections, you can kind of see them. There's a little square one and a little silver one. Those are thermal fuses, and they're designed to blow if they get too hot. These resistors will get really hot if something's going on, and it'll blow those thermals. So if you've got too big or too high ratings on the thermal fuses, which these are about 2.5 amp to 3 amp, if you get any higher than that, then you're going to burn the board, because it's not going to blow the fuse. It's going to keep going until it just don't work anymore, and that's what you see a lot of when you see this. Sometimes it happens even with the original board, but yeah, so you don't want to put too big of a fuse on there. And the thermals, you need to make sure you match the thermals, because sometimes it gets to the point where you might as well just salvage the parts on it, and that's kind of what I did on this. I salvaged what I could. I could repair this, but sometimes they're so labor intensive that it's not worth it. It just depends on, you know, if you can get the parts or not. In a situation like this, see how bad that is? I'm probably going to salvage it for parts. It's just too much work. It can be done, but it's just so much work. This is your trigger board. Each one of these SCRs serves a purpose, and obviously if you've ever worked on these, something in here, one of these or two of these will go out and then it won't work. And this is your typical issue. If you don't have a blown MOV, which usually is black if it is blown, then you're probably going to have one of these go out. You need to learn how to test these, and you need to learn how to test them under a load. That way you know if it's working or not, because these things sometimes will fail and they'll kind of still work, but they're not working correctly. So that's another tip. And these go here. So this is what makes up pretty much everything except the capacitor, which I usually use, you know, just whatever I have handy as long as it matches. These take a 40 microfarad, I think, and as long as you've got something halfway decent or pretty close, then it'll operate so you can test it. That's the reason why I use this. It's small and I can test with it. But they operate with a 40 microfarad, and you rarely ever see those go out. Since I need to test these two transformers, I'm going to see if I can do a quick fix on this. Alright, let me get this crap out of the way. This is what I'm looking for. So I'm going to put some resin in here. If you don't have this, it makes it very difficult to solder to it. I put some, let me get this open, copper trace material. You can buy this stuff in pretty big rolls, just copper. It has some adhesive on it, which will help hold it in place while you solder it. I just keep a little bit here because the roll is a big pain in the butt, and it's, you know, it's in the way, so that's what I use that for. Then we're going to get some solder going on this. Just like that. It'd be a good idea to cover it. And really, when you look at it, all this stuff probably needs to be resoldered. But for now, I think we'll be fine to test it. I've just got to get everything connected. Okay, this is the one I rebuilt. Another thing you're going to find problems with is finding a good source of these SCRs. I've had some issues where I bought them from off of eBay and they're not SCRs. I don't even know what they are. Some kind of transistor, but it's in the same package. It looks exactly the same, labeled the same, but it's not the same, and it's a waste of your money. You get screwed on that deal. Make sure you buy from a reputable source, DigiKey or Mouser or something. We need to replace this one. I'm going to do that, and I'm not going to even see if these others need to be replaced. And let's see what happens. Well, those Zaribas are loud. That's my example of how to fix just about every Zariba or American FarmWorks. I've got multiple jobs, but this is what I do in this field. Is I repair fence chargers, and I usually repair the boards. I'm not like a lot of guys that just swap boards out. And since these boards are getting almost impossible to buy, I figured I would put a video out to kind of give you guys an example of how to repair one. And this is a typical repair. Like I said, go over it one more time. You're either going to have a primary or a secondary out on a transformer. The first thing you check is your power in. So you may have a blown thermal fuse. There should be continuity across both of those fuses. If you have continuity across those fuses and something's not working, your next step is actually to test these SCRs on this board. Sometimes you get lucky and you have a dead shorted SCR like this, where you can run your beeper like that and know, well, it's shorted. Okay, but that's lucky. A lot of times one of these will go out and you won't get a direct short. You'll have partial fail or something weird and it won't work. The other easy thing to check is going to be these MOVs, which is what triggers the system to fire. These will burn up a lot of times, and you could tell by looking at it. And then beyond that, you need to have some skill to be able to test your diodes and your other SCR on the board and stuff. You've seen me testing it earlier where I had continuity on both, and it actually shows the correct resistance, so I don't think there's anything wrong with this, but who knows? Let's test it. Yeah, okay, so the other way you can test is the output. The output's really low on this. It should be close to 9,000 volts. You have an arc going on inside, probably the secondary. Usually, yeah, you can hear it now. It's going to eat its way through and just completely destroy itself. So the secondary's blown on this. Probably somewhere back here where you can't see it. Usually you can see it popping. So now we're down to 1,000 volts, 900 volts. So this one is definitely bad. Sometimes you need to hook them up to test them to make sure they've got enough output. Like I said, you're going to be looking for Woo, that's hot. You're going to be looking for 900 volts going in and 9,000 coming out, roughly 10 to 1. You don't want to touch that. That's direct contact to the capacitor. Does that scare you?
Are you okay? I heard that all the way in the other end of the house.
Yeah, I just put these wires back and they touched.
Oh, okay.
And it's pretty scary. It scares the crap out of me every time it happens.
Well, I heard it all the way in there. I thought maybe that's like that.
When you do start testing these units, you want to test them under a load as well, because sometimes they'll just fire and they'll look good on this meter, but if you don't have a load on them, you won't see where you've got possibly a weak capacitor or you've got an issue inside the transformer. So the way you want to determine that is, once you get the idea of about how much this thing should put out, you put a load on it. This is a 390 ohm resistor, and I've got a couple of alligator clips hooked to it. I think some people use 50 ohm resistors. If you pull one of these resistors, power resistors, out of a unit, it'll tell you on the front what it is. This is 10 ohm. It's really too small to do any testing. This one here is 100 ohm. This is probably perfect. You could take 100 ohm and build you a resistor to put across your leads. That way you've got a simulation of a load, like on a fence that's shorted or you know, partially shorted. So by doing that, we know this is putting out almost 9,000 volts. So when I put this load on there, we can check, depending on how far it drops, is how you can kind of determine whether or not your capacitor is getting weak. So this has got 5.2 kilovolt. That tells me it's about right. If the capacitor is getting really weak, you're going to have a lot lower number. And actually this is a little low because I'm running a 30 microfarad capacitor, and these are designed to run off of a 40. So there's a little more punch with a 40, which is going to put you closer to 6,500 volts. When you're testing your unit, you should be closer to 6,000 volts with a decent capacitor, unless you've got issues with your transformer, and this will kind of expose those issues. This load is perfect for discharging your capacitors. So after you've messed around with this and you don't want to hurt yourself, then you can take this load and cross over your caps and get rid of all your voltage that way. So you can handle this, because if you don't, like on these, if you don't go through and discharge each cap, then as soon as you grab the back of that thing, it's going to jump through your hand. Don't ask me how I know. At least 50 ohm. And if you like the video, give it a like and a thumbs up, or whatever you want to call it, because I'll make some more if I know that you guys are interested in these.